Today we will talk about inverse trigonometric functions. So what is a inverse trigonometric function? What is an inverse trigonometric function? So let sine theta is equal to x. Then theta is called sine inverse x. So basically sine inverse x means that angle for which sine has the value x. As we have written, sine inverse half is equal to 30 degree. That means sine inverse half means that particular angle for which sine has the value half. So that is 30 degree. So it means that angle for which sine has the value half, that is 30 degrees. So we have written 30 degree or pi by 6. So here one thing must be clear, as in algebraic expressions 1 upon x is written as x raised to the power minus 1. So generally x raised to the power minus 1 is considered to be the reciprocal of x. But here in this case sine inverse x doesn't mean the reciprocal of sine. Be very careful. This is very common mistake. So I have pointed it out. This is to remember. This is not the concept, but the concept sine inverse x is that angle for which sine has the value x. That is, if sine inverse 1 is there, so we will get 90. If sine inverse under root 3 upon 2, then we will get 60 degree or pi by 3. In the same way, cos inverse x is defined, tan inverse x is defined, sec inverse and cosec inverse. All these inverse trigonometric functions are defined in the same way. So in this video I will explain some of the important formulae which are used in inverse trigonometric functions study. And in my next video I will give some sample solutions of some very important sums. Now we will talk about the first standard result, which is sine inverse x plus cos inverse x is equal to pi by 2. So how do we get this? Let sine inverse x is equal to theta. It implies that sine theta is equal to x. Let it be first. Now, as we know, sine theta may also be written as cos pi by 2 minus theta. So this is equation number 2. Say from one equation and equation number 2 we substitute sine theta is equal to x here in equation number 2. From equation number 1 we are going to substitute the value of sine theta in equation number 2. So we get x is equal to cos pi by 2 minus theta. And by inverse trigonometric concept, it implies that cos inverse x is equal to pi by 2 minus theta. So if we add this and this, if we add up this result and this result, say this is first in Roman and this is second equation. So if we add them up, we add first equation and second equation, we get on the left hand side sine inverse x plus cos inverse x is equal to, on the right hand side we get theta plus pi by 2 minus theta. Here plus theta and minus theta are cancelled and we get sine inverse x plus cos inverse x is equal to pi by 2. So this is the desired result which we wanted to prove. Sine inverse x plus cos inverse x is equal to pi by 2. Similarly, tan inverse x plus cot inverse x is equal to pi by 2, and we can prove this result again in the same way as we have proved this one. So you better try yourself. And third, sec inverse x plus cosec inverse x is equal to pi by 2. So these are three results which are same in nature. So we may prove all these three results in the same way as we have done this one. Now second important point to remember is that cosec inverse x is equal to sine inverse 1 over x, or we may write sine inverse x is equal to cosec inverse 1 over x. How? Let cosec inverse x is equal to theta, let it be 1, and from 1 we get, by the concept of inverse trigonometric functions, cosec theta is equal to x. And since cosec is the reciprocal of sine, we may write it as 1 upon sine theta is equal to x as it is, or we may take the reciprocal of both the sides of this equation. So we have sine theta is equal to 1 upon x. So now sine theta is equal to 1 upon x. So by concept of inverse trigonometric functions, it implies that theta is equal to sine inverse 1 upon x. This is equation number 2, say. Now substituting the value of theta from equation number 1 and equation number 2, we get from 1 and 2, we get here is theta, and theta value is cosec inverse x from equation number 1. So substituting this value here, we get cosec inverse x is equal to sine inverse 1 over x. So this is similar formulas we have for sec inverse and cos inverse. So sec inverse x is equal to cos inverse 1 over x, or cos inverse x is equal to sec inverse 1 over x, and tan inverse x is equal to cot inverse 1 over x, or cot inverse x is equal to tan inverse 1 over x. Now the next important formula is sine inverse x plus sine inverse y is equal to sine inverse x under root 1 minus y square plus y under root 1 minus x square. So now we are going to prove it. Let sine inverse x is equal to alpha. It implies that x is equal to sine alpha. That would be equation number 1. And sine inverse y is equal to beta implies that y is equal to sine beta. say equation number 2. Now, as we know the formula of sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta, and this may be written as sine alpha as it is, and cos beta may be written as under root cos square beta, and cos square beta may be written as 1 minus sine square beta. So cos beta may be written as under root 1 minus sine square beta, plus again cos alpha may be written as under root cos square alpha, and cos square alpha may be written as 1 minus sine square alpha, and sine beta as it is. What we have done, we have transformed the cosines in terms of sines in the whole expression. Sine alpha remains as it is, and this is cosine, so we have changed it, or we have transformed it in the form of sine. Here cosine function, and we have transformed it into in terms of sine function and sine function as it is. So we have transformed all the trigonometric functions in form of sines. Then, as from equation number 1, sine alpha is equal to x and sine beta is equal to y. So write down on the right hand side x in place of sine alpha and y in place of sine beta. We get x under root 1 minus y square plus under root 1 minus x square into y, or x under root 1 minus y square, or we may write y before this root because it looks good, y into under root 1 minus x square, and then finally we get sine alpha plus beta is equal to this much, right? So sine alpha plus beta, because left hand side is same, only we have simplified the right hand side. So in this step we write this relation in terms of inverse trigonometric functions, and because the basic concept of inverse trigonometric function is if sine theta is equal to x, then it implies that sine inverse x is equal to theta, that is that angle for which sine has the value theta. So by this we may write this expression in terms of inverse trigonometric function. So if we transpose this sign to right hand side, it becomes inverse, and we may write this relation as alpha plus beta is equal to sine inverse x under root 1 minus y square plus y under root 1 minus x square. Now alpha plus beta we get on the left hand side, and on the right hand side we get this expression. Now from equation number 1, as we have assumed initially sine inverse x was alpha and sine inverse y was beta, so we may replace sine inverse x by alpha by sine inverse x and beta by sine inverse y in this relation. So we have replaced alpha by sine inverse x, so sine inverse x, and beta by sine inverse y, and on the right hand side we write the same expression, sine inverse x under root 1 minus y square plus y under root 1 minus x square. So here we get our standard formula, sine inverse x plus sine inverse y is equal to sine inverse under bracket x under root 1 minus y square plus y under root 1 minus x square. In the same way we can prove the second standard formula of the same kind, which is sine inverse x minus sine inverse y is equal to sine inverse x under root 1 minus y square minus y and 1 minus x square. So the difference between the first formula and this formula is only of this sign. We have proved sine inverse x plus sine inverse y is equal to sine inverse x under root 1 minus y square plus y under root 1 minus x square, and here in this formula there is only minus sign in place of plus in the first one. So sine inverse x minus sine inverse y is equal to sine inverse x under root 1 minus y square minus y under root 1 minus x square, and the proof of this formula is just the same as we have done the first one, so you better try this one yourself. Now third formula is cos inverse x plus cos inverse y is equal to cos inverse xy minus under root 1 minus x square under root 1 minus y square. Now we have to prove it. Let cos inverse x is equal to alpha implies that cos alpha is equal to x. Let it be 1, and cos inverse y is equal to beta implies that cos beta is equal to y. Let it be equation number 2. Now we know the formula of cos alpha plus beta. The formula of cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta. Here what we have to do on the right hand side, we have to transform all these trigonometrical ratio in terms of cosine. So these two functions are only in cosine, so cosine alpha and cosine beta remain as it is, and we have to write down sin alpha and sin beta in terms of cosine. How? Sin alpha may be written as under root sin square alpha, and sin square alpha, as you know well, is equal to 1 minus cos square alpha, so we may write it as under root 1 minus cos square alpha. In the same way, sin beta may be written as under root 1 minus 1 minus cos square beta. Now, as we have from equation 1, cos alpha is equal to x and cos beta is equal to y. So putting cos alpha as x and cos beta as y in this expression, we get x y minus under root 1 minus x square under root 1 minus y square. So finally we have cos alpha plus beta is equal to xy minus under root 1 minus x square under root 1 minus y square. So by inverse trigonometric functions concept, it implies that alpha plus beta is equal to cos inverse of the whole right hand side xy minus under root 1 minus x square under root 1 minus y square. Now initially we have assumed cos inverse x as alpha and cos inverse y as beta. So alpha may be replaced by cos inverse x and beta by cos inverse y in this expression. So we have cos inverse x plus cos inverse y is equal to cos inverse xy minus under root 1 minus x square under root 1 minus y square. So this is the result we wanted to prove. Now in the same way, second formula in cosine inverse, which is cos inverse x minus cos inverse y is equal to cos inverse xy plus under root 1 minus x square 1 minus y square may also be proved in the same way as we have done this one. So this one you will have to try yourself. Now the next formula we are going to prove is tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So proof, let tan inverse x is equal to alpha implies that x is equal to tan alpha, let it be equation number 1, and tan inverse y is equal to beta implies that y is equal to tan beta. So now we have to write the formula of tan alpha plus beta, which is equal to tan alpha plus tan beta upon 1 minus tan alpha tan beta. Now as we have from equation number 1 tan alpha is equal to x and tan beta is equal to y, we may substitute for tan alpha and tan beta in this expression. We have x plus y because tan alpha is x and tan beta is y, so x plus y upon 1 minus xy. Now simply we have tan alpha plus beta is equal to x plus y upon 1 minus xy. So by inverse trigonometric functions concept, we have to transpose tan to right hand side. It becomes alpha plus beta is equal to tan inverse bracket x plus y upon 1 minus xy. Now here in this expression we have to substitute alpha as tan inverse x and beta as tan inverse y as we have assumed in the beginning. So alpha is tan inverse x, so we get on the left hand side tan inverse x plus beta, beta is tan inverse y, so plus tan inverse y is equal to tan inverse bracket x plus y upon 1 minus xy. So this way we have proved the formula. In the same way you may prove tan inverse x minus tan inverse y is equal to tan inverse x minus y over 1 plus xy. So try this formula yourself. Now the next important formula of inverse trigonometry is 2 sine inverse x is equal to sine inverse 2x under root 1 minus x square. So now we are going to prove it. Let sine inverse x is equal to theta implies that x is equal to sine theta. Let it be equation number 1. Now we have to write the formula of sine 2 theta as we have done this trigonometry, circular trigonometric function in our previous class. So we must know the formula of sine 2x, 2 theta, which is 2 sine theta into cos theta, or sine 2 theta is equal to 2 sine theta as it is. Now we may write cos theta as under root cos square theta, and since cos square theta may be written as 1 minus sine square theta, so we may write cos theta as 1 minus sine square theta. Now as we know well, sine theta is equal to x from equation number 1. So we may replace sine theta by x here in right hand side. So we get 2x under root 1 minus x square. So finally we have sine 2 theta is equal to 2x under root 1 minus x square. Now by inverse trigonometric functions concept, if sine 2 theta is equal to 2x under root 1 minus x square, it implies that 2 theta is equal to sine inverse bracket 2x under root 1 minus x square. Now, as we have assumed in the beginning, sine inverse x is theta. So theta may be replaced by sine inverse x. So here we may replace theta by sine inverse x. So we get on the left hand side 2 sine inverse x is equal to sine inverse 2x under root 1 minus x square. So we have proved it. Now the next important result of inverse trigonometric functions is 2 cos inverse x is equal to cos inverse bracket 2x square minus 1. So in the same way we may prove it easily. Let cos inverse x is equal to theta implies that x is equal to cos theta. Let it be equation number 1. Now write down cos 2 theta formula in terms of cos. As we know, there are 3 forms of this formula cos 2 theta, which is 1 minus 2 sine square theta, and the second one is 2 cos square theta minus 1, and the third one is 1 minus tan square theta upon 1 plus tan square theta. But here we have to use the formula of cos 2 theta in terms of cos. So that is 2 cos square theta minus 1. 2 cos square theta minus 1. So 2, and since cos theta is equal to x from equation number 1, we may replace cos theta by x. We get 2x square minus 1. By inverse trigonometrical functions concept, if cos 2 theta is equal to 2x square minus 1, so it implies that 2 theta is equal to cos inverse 2x square minus 1. Now finally, as we have assumed theta is equal to cos inverse x, so we may replace theta here by cos inverse x, and we get 2 cos inverse x is equal to cos inverse 2x square minus 1. So now the next formula is 2 tan inverse x, and the formula for 2 tan inverse x is written in the 3 forms, or we may say there are 3 formula for 2 tan inverse x. The first one is 2 tan inverse x is equal to sine inverse 2x upon 1 plus x square, and the second one is 2 tan inverse x is equal to cos inverse 1 minus x square upon 1 plus x square, and the third one is 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. So we have to prove it one by one. We have to prove them. So first one we are taking now. Proof the first one. For that, let tan inverse x is assumed as theta. Let it be 1, and it implies that x is equal to tan theta. Let it be equation number 2. By inverse trigonometric functions, if tan inverse x is equal to theta, then x must be equal to tan theta. You know that. We have to write down the formula of sine 2 theta in terms of tan theta. As we know, the formula for sine 2 theta in terms of tan theta is equal to is sine 2 theta is equal to 2 tan theta upon 1 plus tan square theta. So as from equation number 2, tan theta is equal to x, we may replace tan theta by x on the right hand side of this x equation. So we get 2x upon 1 plus x square. So sine 2 theta is equal to 2x upon 1 plus x square. So by inverse trigonometric functions concept, we have to write down the value of 2 theta, which is sine inverse 2x upon 1 plus x square. Or simply for remembering, you may consider this algorithm that whenever you transpose any circular trigonometric function to other side of equality, it becomes inverse. So simply in order to remember, you just keep it in mind. Sine is transpose only leaving the angle, so it becomes inverse here on the right hand side. So here angle 2 theta is left and sine becomes sine inverse on the right hand side. Equation number 1, theta is equal to tan inverse x, so we may replace here theta by tan inverse x, so we get 2 tan inverse x is equal to sine inverse 2 1 plus x squared. Now the second formula is used with the help of cos 2 theta formula in terms of tan theta, which is cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta, and you better try yourself. And the third one is proved with the help of the formula of tan 2 theta in terms of tan theta, which is tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. Remember the difference between these two. Remember the difference between these two formulae is only of this sign. Sin 2 theta is equal to 2 tan theta upon 1 plus tan square theta, and tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. So there is only difference of this sign. There is plus and here is minus. So by the same assumption, on the right hand side, tan theta may be written as x. So we get 2x upon 1 minus x squared. And if we transpose tan to right hand side, it becomes inverse, and we get 2 theta is equal to tan inverse 2x upon 1 minus x squared. And here theta from equation number 1 may be replaced by tan inverse x. So we get on the left hand side 2 tan inverse x is equal to tan inverse 2x upon 1 minus x squared. So this way we have proved this formula. Second formula I left for you, so you should try the second one yourself. Now the next three important formulae of inverse trigonometry are 3 sin inverse x is equal to sin inverse 3x minus 4x cube, and 3 cos inverse x is equal to cos inverse 4x cube minus 3x, and 3 tan inverse x is equal to tan inverse 3x minus x cube upon 1 minus 3x squared. So let us try the second one and third one, because now every time I am leaving the second one for you. Now this time I am leaving the first one for you, and I will explain the second and the third one. So second one, proof of second one is, so as you know, 3 cos inverse x. First we write the formula as it is. 3 cos inverse x is equal to cos inverse 4x cube minus 3x. Now we have to prove it. So first we have to assume this as theta. Cos inverse x is equal to theta, which implies that x is equal to cos theta. Let it be equation number 1. Then we will write the formula of cos 3 theta of circular trigonometric functions, as we have done this portion in previous class. So cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. And as we see clearly, cos theta is equal to x by equation number 1. So we may replace cos theta by x in this expression. So we get 4x cube minus 3x. Now we get cos 3 theta is equal to 4x cube minus 3x. Transposing cos to that side, leaving the angle on left hand side we get 3 theta on the left hand side, and cos becomes on transposition cos inverse. So we get on the other side cos inverse 4x cube minus 3x. Now from our assumption, cos inverse x was assumed as theta, so here theta may be replaced by cos inverse x. So we get on the left hand side 3 cos inverse x, and on the right hand side cos inverse 4x cube minus 3x. So we have proved the second formula, that is 3 cos inverse x is equal to cos inverse 4x cube minus 3x. Now we have to prove the third one. So here we let tan inverse x as alpha or beta or theta, whatever. It implies that x is equal to tan alpha. So now we have to write down the formula of tan 3 theta, which is equal to 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now from equation this, let it be equation number 1. So from here we get, we have written tan 3 theta, so if we better write it theta, it doesn't matter. By mistake we have written here alpha and here theta. So let it be theta, so tan inverse x is equal to theta, then x is equal to tan theta. Now tan 3 theta formula is this, and we have to replace tan theta by x from equation number 1 here on the right hand side. So we get 3x minus x cube upon 1 minus 3x square. Now simply on the left hand side we get tan 3 theta, and on the right hand side we have 3x minus x cube upon 1 minus 3x square. Now simply by inverse trigonometric functions concept, if tan 3 theta is equal to this much, then 3 theta is equal to tan inverse 3x minus x cube upon 1 minus 3x square. And replacing theta by tan inverse x, from our assumption we write 3 tan inverse x on the left hand side, and on the right hand side tan inverse 3x minus x cube upon 1 minus 3x square. So we have